In this lesson, we are going to start looking at quadratic functions, but instead of graphing by hand, we're going to use technology to help us analyze and answer different questions about our function. So for example, on a forward somersault dive, a diver's height h meters above water is given by this function where t is time in seconds after the diver leaves the board. So we already know that if I was to, let me get my drawing pen here, if I was to visualize this, here's a certain height of the diver, they're going to jump and they're going to go in. If I was to visualize it, it would look something like that. But what I'm going to do is I'm going to sketch this, so I'm going to plug this function into technology, and the technology I'm going to use is a Desmos graphing technology. So if you go and Google desmos.com, you'll find it. And it's excellent graphing technology. You just go here, it gives you a nice graph. It has a little keyboard here and you can type everything in just as you see it. So I'm going to type in negative 4.9, and I don't have to use t, I can use x squared plus 6x plus 3. Whoops, it's not plus 3. And I have all of that in there. You have your little squared buttons, you have all the different functions you need, and it shows up right here. And I can move this around, I can zoom in, I can look at it. But it gives you the whole function. But I know because of this diver, I know that t is only positive and t is this x-axis. And I know my h is only positive and h is my vertical axis right here, right? So when I go to sketch this graph and show on my homework the solution to this, I'm not going to sketch everything. I'm going to sketch the graph. Oops, let's go to draw a bit. I'm going to sketch the graph just in quadrant 1 for this question. Okay, and so I'm going to now put on some important pieces. I'm going to put on the intercepts and the vertex. So when I go into Desmos and I hit a point, you can see it shows me what that is. I can see my y, or my vertical, in this case h intercept, is going to be 3. Okay, and then I can go over here and say, oh, okay, my vertex is going to go up and come back down. My vertex is going to be approximately 0.6, 4.8, and my horizontal axes right here, my axes right along that horizontal point is going to be 1.6, 0. I'm not going to worry about this one over here. It does exist, but in this problem it would be negative time, so I'm not even going to write it. So I'm just going to write the one that makes sense in the context of the problem. So I have all my my h and t axes intercepts, and then I have my vertex. That's all I need on the graph. Those are the pieces of information I need. Then I can answer some questions. What does the h-intercept represent? Well, the h-intercept is our initial height, or the height of the diving board, right? So we can answer what these different things mean. So the initial height of the diver, or you could write height of the diving board. All of those would be correct. When does the diver reach its maximum height? Well, the maximum height is reached at the vertex, and it is the time portion. At 0.6 seconds, we are reaching our maximum height, and our maximum height will be 4.8 meters. Right? So the vertex tells us our max, and what number is giving that max, 0.6 seconds. When does the diver hit the water? Well, they hit the water at a height of 0, or it's going to be this intercept down here. So it's going to be at 1.6 seconds. So once you make your sketch, you can now answer all of these different questions just using your sketch. What is the domain? Well, the domain is the set of all possible times. Well, the time starts at 0 and goes all the way to 1.6. So the time starts at 0, and time is greater than that, but less than 1.6, okay, or equal to. Height, well, goes all the way from 0 height all the way up to a maximum of 4.8. So the range will be from 0 all the way to 4.8. All right, so you can just sketch it using your Desmos, but only sketch the portion that makes sense in the context of the problem. Okay, so let's get rid of that one, and we'll try another one. So now I have a rectangle, and I want to write or sketch a graph as the function to represent the area. Okay, so the area of this graph is going to be length multiplied by width. Okay, I can multiply that all out and type it in, or I can just type it in like that, right? So even in Desmos, it has the brackets, and you can type in 10 minus 3x, close brackets, and then we're going to multiply by x plus 1. Okay, and so again, we have that, and we might have to move things around. I might want to zoom out a bit. There we go. We have a nice visual of what this graph looks like. So we're now going to graph, or make a quick sketch of that. So our sketch is going to look something like this. Okay, and so in this case, what does x represent? This is our x, right? Our area as a function of x. X is not the length, right? X is the value I would use to produce the length. So let's just sketch this whole graph and think about what it looks like. The one thing I do know is I can't have 0 area, okay? So I'm going to sketch, this point is 10 here, it's going through there, and so I'm going to sketch the parabola with positive area. Okay, so if my area is positive, those are all of the values of x's that produce that positive area. I'm going to put in my vertex here. Let's go see what it is. We'll click on it. My vertex is about 1.2, 14. So 1.2, 14 is my vertex. Okay, and then let's look at our intercepts and let's see if they make sense or not. 3.3 repeater, or 3 1/3, and -1. So let's draw those in, -1 and 3 1/3. Okay, so we have all the information we need. Now let's think. Could I use -1 for x? Is that possible? Well, if I put a -1, I get 0. All right, so I can't have 0, but I can have anything a little bit higher than -1. If I use 3.3 here in this one, I get 0, right? Because 3 1/3 times 3 is 10, 10 minus 10 is 0. But I can have anything less than 3 1/3, and I get a positive length and an area. So I can have a negative x because it produces a positive length. So all of this part of my parabola is okay because it's a positive area that's possible. Okay, so now I'm going to use this information to answer some questions. Okay, so I've labeled everything, my x-intercepts, y-intercepts, vertex. What do the x-intercepts represent? Well, the x-intercepts represent the value of x, right? The value of x that give 0 area, right? Area is 0, right there, okay? So those are the points in which you stop. You can't have x beyond those points. So basically, the values of x that produce a positive area have to fall between -1 and 1/3. So that would be my domain. My domain is going to be x has to be between -1 and 3 1/3, but it couldn't equal because you can't have 0 area. Okay? Whereas my range is going to fall between 14 and 0. Could it equal 14? Yes, you can get a maximum area of 14, but nothing greater than that, because once x goes beyond 1.2, area starts to get smaller again. So my maximum area is 14, my minimum is 0, but 0 doesn't make sense because then the rectangle wouldn't exist. So my range, or my area, is going to be bigger than 0, but less than or equal to 14. Okay, so that's a little bit tricky. You really have to stop and think and analyze this graph. Does this have a max or min? Well, it has a maximum. The maximum is 14. That's the max area. Area is 14 maximum. What is the max or min? Well, I just answered that in what it represents. All right? So, using your Desmos, you can graph it and analyze the problem and really think it through. All right, we'll try one last question. So here I have a rectangle, but I put another line through this rectangle. Okay? The area of the rectangle, I can put as many lines as I want through this rectangle. The area of this rectangle doesn't change, right? The area is always length times width. But if I wanted to actually build a fence with all these lines, then the amount of fencing determines how big of an area I can create. So in this question here, we'll call this whole width y. We'll call that length x. That means this width is also y, and this length is x, and this length is x, right? We know the area, regardless of all these x's and y's, we know the area is length times width. That never changes, right? Length times width, simple, okay? But since we have 300 meters of fencing defined in this, then I know that the 3x lengths plus the 2y lengths has to add up to 300, right? So now if I want to write a function that represents the area in terms of its width, in other words, in terms of x, I need to replace this y with what y equals in terms of x. So I'm going to go over to this equation and I'm going to solve for y, right? This is the amount of material I need in terms of x and y, and I'm going to use this, right? I'm going to divide now by 2. So I'm going to get y equals 150 minus 1.5x. And now this y equals 150 minus 1.5x can replace that y. So area is going to be x multiplied by 150 minus 1.5x. Or if I multiply the x in, I can leave it like that, or I can multiply it in. I get 150x minus 1.5x squared. Okay, so now I have my quadratic equation to represent the area of this in terms of x, given I have 300 meters of fencing. Okay, if this was 400 meters of fencing, I would have had to plug in a different expression, and then my area function would change. So this is particular to having 300 meters of fencing and only one, right, line going through the middle. If I had 2 lines going through the middle, that would be 4x plus 2y. So then again, that would change, which would make this change. Okay? So now that I have this function, I'm going to now type this in over here, and I'm going to get 150x minus 1.5x squared. And I have my function, but it doesn't look like a parabola. But because it's squared, I know it has to be a parabola. So what I have to do is I have to start to go, well, maybe it is a parabola, and I have to zoom in or out, right, and try to find what this looks like. So you have to kind of fiddle and look around. Oops, there's the other line of my parabola. And you can move your graph around and say, okay, well, this is definitely very vertically extended. Well, I'm going way up there. Oh, I finally found my vertex. My vertex is at 3,750. So when I go to draw this graph here, right, the maximum height is going to be, the vertex is going to be 50, 3,750, right? And if I go all the way down, let's zoom way back out. If I go all the way down to the bottom here, we can see that that point there is 0, 0, and that is 100, 0. So those are the main key points I want to get. So this is 0, and this is 100. And it's going to go all the way up and all the way down, right? And so we have all of our information. We have our intercepts and we have our vertex. So now we need to figure out, what do these mean? What does this vertex mean? Well, remember, it's x, comma, a, area. This is area equals, right? This is area is a function of the width. So you need to really remember what your variables represent. So if area is a function of the width, that means when I have a width of 50, I have an area of 3,750. And based on this parabola, I can see that as I plug in different widths, my area gets larger and larger and larger, but once I hit a 50 width, I get the largest possible area. Then if I go further past 50, my area starts to get smaller again. And once I reach 100, I have 0 area. right? So I have no more area at 100 because it's impossible to get to 100 because you'll no longer have enough material, right? Because if I used 100, I'd use all the materials on my x's, 100, 100, and 100 would give me 300. I have no more value to use for the width of that. Okay? So what does the vertex represent? It represents the max area of 3,750 given a width of 50. Okay? It would have a maximum because my parabola opens down. This represents a max. And that is what the max is. And so again, you can answer all these questions. Sometimes you have to look hard for that parabola because it's really skinny and you have to zoom up, down, move it around, all right, and try to find it in your Desmos graph. Okay. And so that is using Desmos to help us solve different problems given technology.